Hi everyone, it's Logan here again, and you can see I got my new Stator running. That's kind of cool. You can actually see the little reflective tape that I use to measure the speed with a laser tachometer. That's looking pretty neat. But so I got it running. That's only one phase. It's only running at 6 volts, and right now 1.1 amps. Let's see what RPMs we're at. 280, about 280 RPM. That's just one phase at 6 volts. The final version is going to be running at 24-ish volts with 3 phases, so it's going to be a lot more powerful. I've had this thing running up to 12 volts on one phase. Now, right away I want to say that sound you're hearing is because I have mismachined this. This is the new Stator. So there's the old Stator I pulled out. I'm going to be recoiling it with some new wire. This one, my manufacturing processes are not all that great, so it's off slightly. So I have to get in there and I think maybe glue down one of the magnets again, or shift it just slightly or something. Shave off a millimeter of half a millimeter of steel or something off the Stator. We'll see. It's going to get fixed, but it's running. And it's running pretty good. So I'm actually going to take this apart here and show you what I did, what I changed inside. If you haven't seen the other parts of this series yet, the first one I'm going to put a link, say right here, right now, to go see the first one. I highly recommend checking that out. And then I'd also recommend, when you're done watching this video, watch the playlist for all of them, because it's going to explain everything that's going on here. But I'm going to take this apart here, and I'll be back in a second to show you what it looks like inside. Okay, so before I pull it out completely, I'd like to show you what it looks like inside there. Now, obviously, because the other bearing is gone, it's attracted directly to the magnet. When the bearing's holding it in, it's holding it pretty much dead center. Although I think it's off slightly, which is why it's impacting. And I'll take this out completely in a minute, but you'll be able to see it's actually starting to rub on the magnets up there, which obviously it's not supposed to do that. So I got to figure out exactly how to do it. I think I basically have to recut this whole thing more accurately, so it's holding it in the center even more accurately than I have it here. Either that, or I may end up having to shave a little bit off of the top of the Stator here. But the changes I've made since the last one. Here's the last Stator I made. And this had 22 gauge wire. And all of these were in parallel. These right here are the little Hall sensors. And again, I would definitely recommend watching the other videos to learn a little bit more about this. But these are the Hall sensors, and these are actually what detect the magnets as they spin around. So as the magnets spin, the Hall sensor detects them and turns on the coil at the exact right time. And there's 3 different phases, and you can see in this upgraded one here, I've actually color-coded them so that the wires coming out were easier to tell. So the green is one phase, they're all connected. Red is another, and the amber is another one. It's like a little stoplight in there. And this one, they were all the same, they're a little bit harder to tell. So what I did here was a couple things. One, I upgraded the size of the wire. So I went from 22 gauge to 20 gauge. That allows me to handle about 50% more current running in the motor. Because one of the problems is this was it was just too much current. It was getting too hot. Another problem, and it's kind of hard to tell, but I did all of these in parallel, which in some ways was a good thing. What I mean by that is that each one of these was independent. It would wrap around, so it would go in, wrap around, and then come out. You can see the wire here. It's just a whole bunch of them. It has 18 wires running through there. One going in, one going out for each one, and 9 of them. What I did here is a little different. Basically, it comes into one, and then it goes into the other one, then the third one, and then comes back out. You can see all the, you can't really see all the wires in there. I'll show you in a minute. So now instead of being parallel, they're all in series. Why did I do that? Well, it is adding 3 times the amount of resistance in the wire, which means there's less current, so it's less likely to overheat. But because the wires themselves have something like 50% less resistance, I end up with only a total of something like 30% more resistance overall, but I also have wires that can handle way more current. So it ends up working out better. I'll be able to get a much higher amperage in there at a higher voltage. This, even just at 9 to 12 volts, was overheating. I mean, it was getting up to like 8 amps, which is way more than this wire can handle. So this should be pretty much solving that problem. It's also way easier on the wire front. Let me pause this here and I'll get right back. I turned off the flash because it was tough to get in close here, but I got it out, and you can see there's a few more things that I have to do to it still. Now this tape is not the final thing that's going to hold it in. I'm going to glue these Hall sensors in place. I just wanted to test to make sure that they were in the right place before I glued everything down permanently. So that tape is going to be removed there. So, for those of you who want to know the stats of what this was achieving, at 12 volts, I was only running 1 phase at a time because that's the only number of alligator clips that I have. If you haven't watched the other ones yet, I have these wires here, which I've cable sleeved, and they're running into this 24-pin connector. And that runs into this. I might have to turn the motor or the lights on to actually see it. But basically that is a very large heat sink with a bunch of transistors. You can watch the other videos if you want to see more specifically about how I was making that. So that allows me to run all 3 phases at once. And I got a couple 12-volt computer case fans to provide some airflow to cool that down. Because at full bore, those are going to get pretty warm. But just running the one stator, this thing was, the one phase, this was easily able to cool it down at 12 volts. Anyway, so the stats. Just running 1 phase at a time at 12 volts, this thing was up to 840 RPMs. When I tested the torque, what I did was as this thing was spinning, I slowed it down. I put something up here which braked it down to about half speed, 420 RPMs. While this is probably a very informal way of doing it, that is, if you ever heard the term brake horsepower, that's effectively what they do, except they do it on a dynamometer instead of by hand. But I basically put something up against this, slowed it down to 420 RPMs, and then looked at the amperage. So the way to determine the specific stats is you take the volts, which in this case was 12, times the amps, and then that's how many watts you have. Divide that by 746 and you get number of horsepower, which off the top of my head I don't remember what that was. My guess would be somewhere around 40 watts. So, probably 0.06, 0.08 horsepower, something like that, off the top of my head. And then to get the torque, you take the horsepower number times 5,252 and then divide by the RPM. So at 420 RPM, which is the equivalent on this wheel, this is a 10-inch wheel, that's the equivalent of about 12.5 miles per hour. So one phase at half speed, 12.5 miles per hour, which means it was actually running about 25 miles per hour at full speed, it was able to create 0.72 foot-pounds of torque. So what that equates to when I run it through the equation is that one phase in one motor running a go-kart at 12.5 miles per hour when the go-kart weighs about 96 pounds. So you figure I'm going to have 3 phases, so that's going to be 96 times 3, so it's about 300 pounds. I'm going to have 2 motors, so that's 600 pounds, and they're going to be at 24 volts, so that's about 1,200 pounds at 12 miles per hour. Now, of course, that's not a perfectly accurate number. That will change a little bit, but that'll give you an idea of what this go-kart will be able to do, which means chances are I'm going to be able to get it, 200 to 300 pounds moving at 30 miles per hour. So this should be pretty good. And if you want to see a little bit more about how this works here are the magnets themselves. Hold on a sec. There we go. All right, here are the magnets themselves, and you can see where the steel was starting to scrape. They haven't damaged the magnets, but they're certainly not supposed to be scraping. The reason I have this taped on here, they are actually glued in, but I just wanted one extra layer of protection so they didn't go flying off inside the motor. I haven't seemed to need that. They seem to be on there just fine. A little bit of give, but they're actually holding each other in, plus they have super glue behind them. So they are holding themselves in, but I figured I have that on there just in case. The proper thing to do is really to get countersunk magnets where they have a big hole there, and you can put a screw right into it and hold it in place that way. And that probably will exist in the final version of this. In the meantime, however, this is what I got. So there are 12 magnets, and there are 9 teeth here. And if you want to know how I came to that specific number, I'm going to put a link in the description. There is an online calculator that will show you exactly how many teeth to use, how many poles to use, and those combinations. Now the other thing is the way you wrap it. Because of this 3 to 4 ratio, 3 teeth for every 4 magnets, you can basically keep this exact configuration. So whichever way you wrap it this way, say you wrap it clockwise, let's see, which way do I have this? Yes, this is wrapped clockwise. It then immediately goes to the next one behind it, and that one is also wrapped clockwise, and then to the other one, which is also wrapped clockwise. There are different configurations, however, that calculator will show you. In fact, some of the really confusing ones, if you have a lot of teeth, you may end up going clockwise here, then right next to it counterclockwise, then skipping 2, then doing the same thing, then skipping 2 and doing the same. It can get a pretty complicated configuration, so that's why I use that calculator. It makes things super simple. Now, one other thing I'd like to point out. These magnets are about 1 inch square, or not about, they are 1 inch square. Well, the reason I chose that particular size is because that's all the space I have in here. If I were going to make it wider, this wheel wider, then I would like to use bigger ones because bigger ones tend to have better force. Also, what I've noticed is that a thicker magnet tends to produce more torque and lower speed. And a thinner magnet tends to produce more speed and less torque. So if you're creating a motor for, say, an airplane, an RC airplane propeller, you're going to want thin, weak magnets that spin very, very fast instead of the other way around. Same thing if you're making like a Dremel tool or something. You're going to want something that spins very, very fast, not something that spins with a lot of torque. You only have to have enough torque to, say, spin the propeller. Now, you might notice, if you know anything about motors, these are only about 3/4 of an inch, these teeth here, instead of an inch. They should be an inch. That comes down to my limitations with manufacturing. The wires themselves are, the thickness of the wire wraps here is about an inch. But it is really, really tough to manufacture a tiny little bit of metal and then glue it on here. These are called shoes, by the way. These are the Stator teeth as a whole. And this top part, the part that comes off to the sides here, that overlaps with the magnet wire, that's called a shoe. And so really the proper thing to do is to cut out little shoes and then glue them on top of here to be the thickness of the wire. Why do you want that? Well, the strongest part of the magnet is on the border right here where they are overlapping, right here in this edge. That's the strongest part of the magnet. And it's the same on here. The strongest part of the electromagnet, which is what this is going to be on the edge. So you want that to be the same size, the same length as the edge of the magnet, so that you're getting the most force pushing against each other. So really this motor could have even more power were I to, or more torque were I to complete this. And hopefully, you know, that will eventually happen, but it's so difficult when you're just using, say, a Dremel tool. That's not the bit I use for it, but when you're using a Dremel tool to cut out around the teeth where it's supposed to go, it's really, really tough to hold a little tiny piece. But hopefully I solve that problem eventually. But as you can see, it's working pretty well. And I'm expecting to be able to get up to some pretty good speeds with this. So now my task is I'm going to redo this. I'm going to tear off all that wire, unfortunately, but I have to. This is just dust from sitting for a while. I'm going to tear off all this wire and put on more 20 gauge wire in that same configuration and test it. If you are curious about making this yourself, one thing you want to be really, 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 really careful of, and I emphasize really, is that as you're putting this on, as you're wrapping the wire, be very careful to completely insulate the stator from the wire. What they do in the commercially produced motors is that they have a little white paper, that's insulated paper, that they stick in between here. And then the wraps go around the sides of the paper. There's a problem with that here, though, is that that tends to make the wire stick out more loosely, which makes sense. But there's no room for that in here. So I had to wrap the wire real tight. And when you do that, it puts a lot of pressure on the insulation and it will break the insulation. As soon as the insulation's broke, it will touch any exposed non-insulated pieces of the stator and immediately create a short with the body. Now that's bad enough because you can get extra heat and lost energy, which make your batteries drain faster, make your motor run more slowly or with less torque. But it's even worse if that happens to two or all three of the phases. If that happens, they will begin sharing current, which is not only bad for performance, but even worse is that it will activate some current in one of the phases that shouldn't be active. So in other words, the Hall sensor will be telling it to be turned off, but because it's got a short with another phase, it will be turned on. And the motor either won't spin, it'll spin poorly, it'll jerk around. There's a lot of symptoms of that. This was difficult to achieve. I had the green one entirely wrapped, and what I would do is I would basically put one of the ends here of my multimeter inside here. And then I'd put the other end here to make sure I could get a current across there. I'd put it in resistance mode, so I was basically measuring how much resistance was through it. If I got a number, that meant that there was in fact an electrical path. So I'd put one of the sides in here, put the other side here, test, and I would in fact get a current, which you should because it's all metal. And then I would test it, push this one. I would take it off of there and put it to whichever wire on the phase I was working on. If I got any kind of conduction between there, any kind of number at all, I had to tear off the last couple turns that I made until I no longer got a number. Then I knew that there was somewhere in there that there was a leak, an electrical leak, and I had to seal that. I got the green one entirely on, didn't seem to be any problems. I moved on to doing the red one, And all of a sudden I just decided for fun to test the green one again, and there was a problem. Somehow me monkeying around with the red one, moving this, caused this to create a short. So I had to take off the green one entirely and redo it. That's why you see all this masking tape here. It's not the most elegant solution, but it is electrically insulative. So I ended up putting 2 layers of masking tape around all of the stator teeth and underneath the shoes here too. And I ended up ripping off some of it, but I basically looped it around the top here and cut it off later. I had 2 layers of it on there to make sure that no matter how much pressure this squeezed it with, it wouldn't cut through to the stator. And now I've tested it multiple times and they are completely insulated. So if you're thinking about making your own, that is a very important thing to note. And that's, I think, one of the problems here is I did not do a good enough job with that. I actually ended up using some glue. That's what that the discolored part is. I used some glue there to stop the conduction, but apparently I didn't get all the spots because it was having a problem. So I'm going to redo it, and it takes literally about all day on this particular stator. I think it took me about 6 hours to wrap all these and test them, and then unwrap them, and then retest them, and then rewrap them, etc., etc. But it works now, and I'm pretty happy with it. So I think the next step here is I'm going to redo this because it shouldn't be hitting, and I can probably end up creating more torque if the stator isn't hitting these magnets. It doesn't seem to be wrecking them at all. If anything, it seems to be tearing off some of the steel, and that's what you see, these little bits on here is just steel, I think, that's coming off of the stator from being hit and being attracted to the magnets. But it doesn't seem to be wrecking the magnets at all, which is good because these were not cheap magnets. If you guys want, if you don't want to special order magnets, as I have previously done, the best place I have found besides eBay is a website called K&J Magnetics, or kjmagnetics.com. I'll put that in the description as well. Fantastic. They have almost every type of magnet you could possibly want in practically every single shape. And they will do custom magnets, but it's expensive, so you'll want to order a whole lot of them at a time to make it worth it, per magnet-wise. I think there's like $100 shop setup fee or $150. So if you're just planning on ordering 2 custom magnets, well, you're going to be paying like $200 for it. But if you're planning on ordering a whole bunch of them, say, 48 of these things for 4 wheels, it may just do the trick. That's the next step. Redoing this structure here, and then more accurately machining it so that it's holding the stator perfectly in the center. Interestingly, though, I didn't have that problem with the stator. So it could be that I just didn't cut this quite small enough in some spot, but I don't know. I'll have to play around with it more. But rest assured, this is moving along pretty well. And my next video about this will probably be with it fully assembled, all 3 phases running at 12 volts or maybe even 24 volts on this test bench, and showing you guys the result. I also have some other videos planned. I thought it would be fun, just because I got some extra metal lying around, would be to make something that has, well, I have to redo this here, but this is a few smaller magnets that I had originally got to test this when I was learning about magnets, or motors, I mean. And this is going to be a regular motor instead of an inside-out motor. So the magnets will be in the center instead of on the outside. And I want to hook up some propeller blades for like a helicopter. And I want to see if I can get this thing to lift itself. It's going to be heavy, but it'd be cool to try. So that, I think, will be the very next video that comes out, because machining this thing is going to take a while. But I hope you liked it. Stay subscribed, or subscribe if you haven't. Let me know what more you want to see, because this is fun for me. And if you want to see, something more specifically about how to make motors or how to configure wires or whatever, send me a message or let me know, and maybe I'll make a video of it. I'm always looking for new ideas. And thanks for checking this out. I really appreciate it. Let me know what else you want to see. Like if you like it, subscribe, and of course, have a great day.